Okay, so this is question 13, and 13 reads, the limit as x approaches 0. This means all x's turn to 0 at the end of the question, and then it's going to be sine 4x plus sine 2x all over x. Okay. First thing you're going to notice here is that the rule we're generally looking for is sine kx over x as the limit goes to 1, as x approaches 0. This all turns into 1, provided the angle and the number underneath it are the same thing. So what we have here is we need to make this system happen, but the problem is we only have one x underneath it. So what we're going to do is we're going to use the rule sine A plus sine B, and we're going to look up page 15 of your log tables to do that. And then when sine A plus sine B gets there, we're going to get 2 sine A plus B over 2, and then cos A minus B over 2. Okay. In this question, A equals 4x and B equals 2x. And now what we're going to do is we're going to apply that rule into this question. Alright, so then what we're going to get is 2 sine A plus B is 4x plus 2x, which is 6x. 6x divided by 2 gives you 3x. So 2 sine 3x, and then cos A minus B, which is 4x minus 2x, which is 2x. 2x divided by 2 is cos x. And this is all over x. Now, what we really want to do is we really want to single out the sine and have the x directly underneath it, okay? So in order to do this, we need to have sine 3x over 3x. So what we could do is we could multiply the bottom by 3, and then if we multiply the bottom by 3, we must multiply the top by 3, and then long and behold, this red box here, as the limit as x approaches 0, turns into 1, so it's going to be 2 times 1. We got to remember the 3 is out here as well, so 3 multiplied by 2 will actually give you 6. So it's actually going to be 6 times 1, and then we're going to have 6 times 1. These guys turn into 1, and then it's going to be cos x. Now what we have to remember cos x is when x tends towards 0, cos x turns into 1. So the answer is going to be 6 times 1 times 1. So the answer is going to be 6. Okay, so this question here differs from the previous questions. Okay, so what we're going to know is that there's basically a 2 on the bottom, 2 into 1 minus 2 cos squared x. Now, when doing a question like this, you might need to be on this full section has all been about getting sine kx over sine x or sine kx, getting the same angle. Okay, now this question presents a really different challenge. So the first thing I'm going to do is I'm just going to go in and start factorizing, see if I can factorize something. So I notice that I can factorize the bottom. Okay, that's the first thing I'm noticing, is I can actually factorize the bottom. The second thing I'm going to notice here is that 1 minus, there's a rule from your tables where sine squared x plus cos squared x equals 1. And this means that sine squared x equals 1 minus cos squared x. Now the reason why I did this move is I'm actually looking to see if I can, okay, so the 1 minus cos squared x is going to change into sine squared x, okay? So all we just do here, just a quick rub out. That's way too big of a rubber, but we'll work with that. Okay, so it's going to be 2 into sine squared x now, and we're still on x sine 2x above. Now if you look into your tables as well, and your tables on page 14 of your tables, okay, you're going to see the following formula: sine 2a equals 2 sine a cos a, which in turn means that sine 2x should be equal to x bracket sine 2x here is going to be equal to 2 sine x cos x, and now this is going to be divided by 2 sine squared x, okay? Now examine this really closely. Now what we can do with the sine squared x is that we can cancel one sine x with one here, okay? And then what we're going to be left with is cos x over sine x. Now, okay, cos x over sine x and x over 2 over the other side. So if we just concentrate on the cos x over sine x part, which is this part here, what we can do is we can look up the tables and figure out what this might be, okay? Now, we know that sine x over cos x is tan x, because this is in your tables on page 13, okay? So this means that if you invert both sides, this means that cos x over sine x is 1 over tan x, okay? So what we can do now is we can basically say that there's a 2 on top here, so the 2's can actually cancel as well, okay? So what we're going to be left with is x multiplied by 1 over tan x, okay? And what this will get you is x over tan x, and then the limit as x approaches 0. And as discussed, this formula also works for tan x. Since the angles are the same, this goes to 1. And that's your answer for this particular section. Okay, now this next one's actually quite difficult. We're given the limit as x approaches 0 of x sine x divided by 1 minus cos x, okay? Now the problem with this one is you have no real squares. There's no real specific route to go down. Now one thing that might give it away is this 1 minus cos x part. So if you look up your tables, okay, what's in your tables is sine squared a equals a half 1 minus cos 2a. Now what you could do with this in this scenario is you could basically say that you could rearrange this formula, okay? So when you rearrange this formula, what you could say is that 2 sine squared a equals 1 minus cos 2a, and then what we could say after that is cos 2a. Bring the cos 2a over and the minus 2 sine squared a over the other side. And what we could say there is that cos 2a, 1 minus cos 2a is exactly what we're looking for, because it's 1 minus cos x. So let's replace x in this formula, okay? So instead of having 1, we still have 1, but instead of having 2a, we have cos x. This means that 2a equals x, yeah? So x equals 2a, which means a equals x over 2. So this will mean that this will turn into 2 sine squared x over 2. Okay, let's go up and manipulate this now. Limit as x approaches 0. And now on the bottom, we're going to have 2 sine squared x over 2. Okay, now what we're sort of noticing about the top is that the top is incompatible with the bottom, because there's different angles involved, okay? So in order to change these angles, what we're going to have to do is we're going to have to look at sine x, okay? Now there is a formula for sine 2x. So sine 2x is equal to, sine 2x is equal to 2, sine 2x will work as well, but in your tables is actually 2a. So what we're going to do is we're going to put down sine 2a, and sine 2a from page 14 of your tables is 2 sine a cos a. Okay, and when you do 2 sine a cos a, what you get is the following, okay? So we're not looking for sine 2a, what we're actually looking for is sine x. So sine x, okay? So if 2a equals x, then a must be x over 2. So we're changing this is into sine x over 2 cos x over 2. Now all of a sudden we're actually starting to speak the same language, because basically the angles are the same, okay? So now we can actually start crossing out and figuring out what we need to do. So the first thing you're going to notice is that the 2's are going to cancel each other. This sine squared x over 2 is going to cancel this one up here. And then we're going to be left with limit as x approaches 0 of, and we're also forgetting our x, our friend, the x at the start, who should be lodged in behind the 2. Okay, so what we're going to end up getting here is cos x over 2 divided by sine x over 2. And as stated before, okay, tan A is sine A over cos A. Tan A is sine A over cos A. So this means that if you turn that upside down, 1 over tan A is equal to cos A over sine A. And then what we can do is we can place, you can see this here, this box here. Okay, that's basically cos A over sine A. So that means that it's going to be the limit as x approaches 0 of x, and then inside the bracket we're going to have 1 over tan x over 2. Okay? Now, the problem we're seeing at the moment is that we need the angles to be same. We need an x over 2 on top. Okay? In order to get this x over 2 on top, what we need to do is we need to multiply the top by a half. And if you multiply the top by a half, you must also multiply the bottom by a half. So now the answer is going to be the limit as x approaches 0 of x over 2 inside the brackets, and then we're going to have tan x over 2, and then we're going to have 1 divided by a half. Okay, the two of these will cancel, will develop into a 1 as x approaches 0, and 1 divided by a half is basically the number 2 is the answer, and that is the answer to that question. Some people might be asking, where did this x over 2 come from? Okay, and the x over 2 comes from multiplying this half by this x here, and this develops your x over 2. Okay, and we already know that there's a tan x over 2 underneath. The two of them interact, and as x approaches 0, this becomes 1. This leaves this number 1 here, and this half left over. Hence we have 1 divided by a half, and that answer will give you 2.